Today we'll start talking about the potential energy. There's another kind of energies in physics. One of them is the potential energy. What is the meaning of the potential energy? We'll see that now. Yesterday we started talking about the kinetic energy by using one of our known equations. And we use this equation, V2 square is equal V1 square plus 2ax. Then we multiply it by the mass, then divide over 2. This is the work, because this is the force multiplied by x. From the work, we find the new kind of energy. Today we'll do the same thing. Assume that we have these two experiments. This is the first one. And we know how to deal with them. If we have two altitudes, we have here y2, this altitude, this building, and here is y1. We have a mass. At y2. The second experiment, we have this mass at y1. As we know, we have the gravity downward. We assume the positive direction upward. What we have also. The first experiment here, if we lift our mass to free fall like this, who is the actor? What is the reason that the mass goes downward? As we know, it is the gravity. So the motion of the mass is due gravity. So this work is done by gravity to move the object, because the mass is here, we lift it to move, then it has now a kinetic energy. If the mass moved from y2 to y1, from y2 to y1, so this is delta y, which is y1 minus y2 in this case. What is the work? The work is equal to F multiplied by delta y. What is the force in this case? It is the weight. It is the weight. We have the weight downward, which is mg. What is delta y? It is what? Y final minus y initial. Y final is y1 minus y2. This is the work. We can write it as two terms like this, which is equal to mg y1 minus mg y2. We know how to do that. What about the second experiment? We have y2, y1. Initially, we are at y1. What if we need to lift this object from y1 to y2? We don't need to have any acceleration. We have the weight, which is equal mg. Now look, we have the weight, we have the work. So I will write the weight as mg. I will not deal with it as or F gravity. Now W is for the work. Now, if I need to move the object with constant velocity means the acceleration is equal to 0. What does that mean? Okay. Means that in y direction, we are moving in y direction, is equal to 0. What is the forces now? What are the forces? We have mg downward. We need another force done by us to lift the object upward, plus F applied by us, it is upward, should be equal to 0, because the acceleration is 0. Why? Because Fy is equal to ma, as ma in y direction, as Newton's second law. In this case, I need the applied force is equal to minus mg, because if I move this to the opposite side, it will be negative. Okay, so the applied force, this is applied force, should be equal to mg. Okay, what is the work in this case? Done by the external applied force. It is simple, we cannot write it. It is W is equal to the applied force, which is mg, multiplied by delta y. Delta y, it is y final minus y initial. Okay. I'll put it here because I missed the theta part in the first question. Okay. F, the first part, the first experiment, F is downward, which is mg, downward. Delta y is downward. How much theta between them? Cosine theta. Theta in this case is 0. Cosine 0. Cosine 0 is 1. So it will not affect anything. This will stay the same. In this case, I have the work is equal to the applied force, which is upward. Delta y. It is delta y. Delta y is also upward. Okay. Cosine 0. But F applied is negative mg. This is mg. You can put negative mg delta y, cosine 0 is 1. Or you can put your applied force like this. The applied force is minus mg, which is mg to the negative part. If you now take mg and delta y, the theta between them is 180 or 2 pi or 1 pi, I'm sorry. So in this case, it will be mg cosine 180, as you see in the notes. It's the same. Okay. Now, it is equal to the work in the second case is equal to mg y2 minus y1 with negative sign. Because cosine 180 or negative mg, we have a negative sign. If we put the negative sign on the parenthesis, it will be mg y1 minus y2. Two terms, mg y1 minus mg y2. This is the work. The second case. This is the work. In the first case, they are the same. What is the meaning of that? The meaning of that, we have a new thing. We need to divide it again. Remember here, the work yesterday we see that the work is equal to the change in kinetic energy, which is equal 1/2 m v2 square minus 1/2 m v1 square. Today, there's a difference. Look, we have the work, the both cases is the same thing, which is mgy1 minus mgy2. But the kinetic energy, 2 minus 1. What we need to do now, if we look at this, W is equal to mg y2 minus mg y1. We need to put minus sign for them. If we define mgy as a new quantity, this will be equal to negative the change of that quantity, which I name it U. Now, look, from before we defined kinetic energy is equal to 1/2 mv squared. Now we need to define the potential energy. U is equal to mgy. Look, we have the mass, we have the gravitational acceleration, we have the altitude. This potential energy comes from these quantities, which are the altitude, the position, and the gravity. Because of that, this potential energy named the gravitational potential energy. So we will name it UG. We will deal with another one. In our life, we have many potential energies. Now, any question about these derivations? If you remember some equations, I don't derive it. I didn't derive them. I will not derive them because there is no benefits from the derivation. But here, because we will solve examples using the work and the altitude and because of that, I show you the derivation. And because U is an energy, its units is joules. Any question about that?